Okay. The second big idea in this video is going to take what we've been talking about, the swap and drop method, but apply it to polyatomic ions. There's an extra step that has to happen. Now, just super fast review. Remember, polyatomic ions, we learned these last unit. They're groups of atoms that are bonded together. They act as one ion. So just like how sodium can act as a positive 1, ammonium, which is a polyatomic, it's 4 atoms chemically bonded together. It can also act as an ion that has a positive 1 charge. So they always have a charge, positive or negative, depending on the polyatomic, and these are the 8 that you need to know. Hopefully at this point you know them. I'm not going over them in this video. So if you need to look at them, go back to the polyatomic video. Okay, let's look at an example of an ionic compound that contains a polyatomic. In this case, lithium combined with carbonate. Lithium has a charge of positive 1. Carbonate has a charge of negative 2. So we're going to swap and drop. 1 goes to carbonate, 2 goes to lithium. Put them together, it's Li2CO3. Easy, right? Okay, well here's the question. What happens if you need more than one of your polyatomic? Okay, let's look. So here we've got calcium. Calcium forms a charge of positive 2. Hydroxide forms a charge of negative 1. Let's swap and drop. So I'm going to take my 2, put it down here, take my 1, put it down here. So my formula becomes calcium, and then if I just wrote down what I had here, it would be OH2. Okay, now let's look at how many atoms we actually have here. We have a calcium. According to this, we have 1 oxygen, and we have 2 hydrogens. Okay, so if we count that up, that's 4 atoms. Okay, now let's see if we can do this a different way. So same charges, +2, -1, swap. So this is a 1, this 2 goes over here. Okay, so I write my calcium, don't need to write the 1. Okay, now here's what I'm going to do differently. Because I have a polyatomic, and because I have more than one of that polyatomic, this is a 2, I'm going to put parentheses around my polyatomic. Okay, what this is telling me is that I have a calcium ion, +2. I also have 2 hydroxides. So 2 of these guys. And notice the charges add together, -2, right, -1 plus -1 is -2. Combine that with a positive 2, we get that nice neutral 0 charge that we're supposed to get. Okay. Also, if we count up the atoms, we now have 1, 2, 3, 4, 5. So we actually get 5 atoms out of it. So it turns out that if you have a polyatomic in your formula, and there's more than one of it, you must use parentheses. Okay. Just think poly, meaning polyatomic, equals parentheses. Okay, so the P in poly stands for parentheses when it comes down to the formula. Do not do it this way. Do not forget, okay, do not forget your parentheses. Alright, so let's look at some examples. Here's another example, aluminum sulfate. Aluminum has a charge of positive 3. Sulfate has a charge of negative 2. We swap and drop, so 3 is going to go here. The 2 is going to go right there. Overshot it a bit, but we're good. So we have aluminum 2, Al2, right? And then I have 3 sulfates. I have more than one of the sulfate. I have 3 of them. So I write my SO4, put parentheses around it, and then I put that 3 on the outside. So I have 3 sulfates combined with 2 aluminum ions to give me a nice neutral polyatomic. Notice, I haven't really talked too much about that last step, the reducing, but notice we can't reduce this one, right? It's a 2 to 3. You can't reduce that. The only time you can reduce is if it's going to be like 2 to 2, 3 to 3, 4 to 4, or even like a 2-4, it could be reduced to like 1-2 or something like that, right? But in this case, we can't reduce it to a lower whole number. Okay, last but not least, we've got one more round of practice. Okay, I know it's kind of a long video, you probably want to do your whisk right now, but I challenge you, pause the video and see if you can do these. Did you try them? Hopefully. Alright. Hopefully you tried them. Let's see what we got here. So we have magnesium and nitrate. So magnesium has a charge of positive 2. Nitrate, I've already given you the charge. It's -1. So if we swap and drop, the 2 goes down here. The 1 goes right here. So your formula ends up as Mg, don't need to write the 1, right? And then nitrate, we have more than one of it, so I go NO3, and I put the 2 on the outside. Okay, now we have ammonium. Ammonium has a charge of +1. And then we have sulfur. When it forms an ion, it forms a charge of -2. So I swap and drop. The 1 goes here, the 2 goes here. My ammonium is a polyatomic. I have more than one of it, so I write down the formula. I put a parentheses around it, set of parentheses anyhow, and then this 2 goes on the outside. Then I add my other ion. It's sulfur. I only have one of them, so I don't need to write the 1 here. So it's NH4 2S. Last but not least, calcium has a charge of +2. Phosphate, I've already given you the charge. It's -3. Swap and drop. So 2 goes here, 3 goes here. So my formula is calcium. I have 3 of them. Phosphates, I have more than 1, so I got to put them in parentheses and put that 2 on the outside. Okay, so those are the answers to the practice. Make sure you complete your whisk, and we'll see you tomorrow.